first. The number of mutually okay, distinguishable permutations. Permutations means arrangements. Whenever we say na, how many words can be generated arrangement, so that is permutation. Since of n things, okay, total if n things are given, of n things taken all at a time, of which p are alike, okay, p are alike of one kind and q are alike of second kind and q are alike of second kind, okay, such that p plus q is n, is how many, is, okay, is n factorial divided by repetition. P are alike and q are alike, it implies that upon p factorial and q factorial, okay, p factorial and q factorial. Now suppose p1 of alike, p2 are alike and some are distinct, then what will be the number of permutation? N factorial upon p factorial, q factorial, and then if no repetition, then no problem. Let's do one problem. Question, okay, find total words which can be formed using the letters of the word banana. Bade hanama banana. Banana, B-A-N-A-N-A, banana. So, solution. What is here n? N value. Count the letters. Okay, 6. Okay, and A repeating how many times? 3 times. So you can say P value is 3. And what is Q? Q n 2 times. And remaining are different. So total number of words, how much answer? 6 factorial divided by 3 factorial and 2 factorial. Now solve it. 6 factorial means 6 into 5 into 4 into 3. But already 3 factorial. Then I will not open. Little smart. You have to be little smart. Because 3 factorial downside present. And 2 factorial open, 2 into 1. Then this cancel. 2 2 ja 4. 2 2 ja 4. How much? 60. 60 words can be generated. Suppose if I give you the word Allahabad, A-L-L-A-H-A-B-A-D. Can you tell me total permutations? Direct answer. No need to write N, P, Q. You have to be very fast. Just total count. 2 to 4 to 6, 3, 9. So 9 factorial upon repetition. A how many times? 1, 2, 3, 4 times upon 4 factorial. L 2 factorial. And any other repetition? No. So solve it. 9 factorial means 9 into 7 into 6 into 5 into 4 factorial upon 4 factorial and 2 into 1. This cancel. 2 3 ja. Just simplify, you will get your answer. No problem. This you will get the answer. I don't want answer. I just want the process. You should know how to solve. Now I will give you result. Okay, result I will give you. Important result. Suppose if they add some condition, if they say I want some letters together, suppose in Allahabad if they say all A together, okay, so I will write here 2 result. First result is number of permutations number of permutations of n different, okay, here different, or bracket you can write distinct things. So this will work only if all the letters are different, okay, distinct thing, in which m particular things are always together, are always together equal to n minus m plus 1 factorial, okay, factorial symbol, this also factorial symbol, into m factorial, correct? So if I ask number of permutation of n different things in which m particular things never together, then what should I do? Total minus together. So if I ask if, okay, if m particular things never together, then what should be answer? And total, first I will write total minus, then total minus always together. So total permutation, because all are distinct, so n factorial, there is no division, n factorial minus n minus m plus 1 factorial into m factorial. Okay, one theorem, then based on theorem at least solve two problems, na? So write always together. Suppose this formula is what? In which m particular things always together. Through examples I will tell you. Suppose I will write one example, then I will explain this. Okay, just wait for the example. So the word is triangle. Okay, the word is triangle. How many words can be formed using the letters of word triangle? Okay, triangle, TRIANGL and E, using the word triangle. Now I am giving two conditions. Firstly, all vowels together, okay, all vowels together, and secondly, all vowels never together, all vowels never together. In the triangle, this word is triangle, TRIANGLE. So what is the n value? 8. What is the n value? 8. Is there any repetition? No repetition, so formula is applicable. Correct? I will tell you concept also, because concept also important. Okay, in case study apply formula, and otherwise concept is the guru. Triangle, n value is 8, and they said all the vowels together. How many vowels count? Vowels. Which are the vowels? I, A and E. These all are together. It means this m value is what? M value 3. I want all the vowels together. So according to formula, by formula, what is the answer? First one. By formula, answer of first part. N factor, n minus m plus 1. N minus m plus 1 factorial into m factorial. Now what is n? N is 8. So 8 minus 3 plus 1 factorial into 3 factorial. So 8 minus 3, 5, 6 factorial into 3 factorial. 6 factorial. Correct, na? Eh? 8 1 9, 9 minus 3 6. 6 factorial into 3 factorial. 6 factorial is I think 720 and 3 factorial 24. Whatever, you leave it, okay? That calculation if required you can do, because in the options answer is sometime like this, factorial type, 6 factorial, 3 factorial. Second question, all the vowels never together. So never together means total minus always together. Always together answer is this. And never together answer? Never together answer? Never together answer total minus total minus together. Okay? So total means n factorial. N value is 8. So 8 factorial minus 6 factorial into 3 factorial. Now do you understand why this formula? Because they are asking only those words tell me in which all vowels never together. So what you will do? You have total permutation, total words. In the total words you subtract in which all together. Then remaining is what? Never together, na? That's why we are doing minus. So this is by formula. Now come to concept. Whenever they said I want some particular things always together, so what to do? Those things assumed as a single letter. In the triangle they want all vowels together. So it means they are saying A I E. So do one thing, this pack in a packet and say single letter. Let's say alpha. Okay. Now how many letters remaining? Because this is single letter alpha, and total how many letters were there? Total 5 plus 1, this also, na? 6. So how many total remaining letters? Tell me. Remaining letters 5 plus 1, 6. So whenever you use this, it means always using together, na? Whenever you put alpha means always I A E together putting. So total answer will be 6 factorial, because now all are different. Can I write for you? Remaining letters are T, R, N, G, L and alpha. So now you see here all are different. 1, 2, 3, 4, 5, 6. All are different. It means total permutation 6 factorial, but I A E together they can switch their positions. I A E, correct na? They can switch their positions. I A E. You can also write like this. If you write A I E, then also all vowels together. If you write E I A, then also together. So it means these itself how many times they can switch their position? 3 factorial. That's why you have to multiply by 3 factorial. So formula and concept. Okay. Why we multiply by 3 factorial? Because they can also switch their positions. Suppose if there are 2 distinct vowels, only I and A, then I will multiply by 2 factorial. Correct? कहाँ पे? हाँ तो 6 आएंगे ना, ये कितने तरह, ये 6 तरह से रीअरेंज हो जाएंगे, इसलिए 6 से मल्टीप्लाई. 3 फैक्टोरियल का मतलब 6, 3 into 2, इसलिए 3 फैक्टोरियल बोलेंगे. 3 फैक्टोरियल आया समझ? Then I will give you next question in which letters are repeated. So given word, suppose I am taking a word mathematics. चलो mathematics. MATHEMATICS, mathematics. Huh? 4 vowels. Okay. Now the question is, okay, count when all vowels together. All vowels together. And when all vowels never together. So let's solve the first one. For the first one, firstly decode this mathematics. In this, how many vowels are there? Which are A, E, A and I. Okay. And is there any repetition? Repetition. Already I am solving, listen to me, I am solving first all vowels together. All vowels together I am solving. It means what I will do, I will I will pack it and I will say this is alpha. Okay, this is alpha. Then what are the new letters? New letters. New letters is M, M, T, H, M, T, C, and S, and also alpha. And also alpha. Okay, also alpha. But alpha contains 4 vowels. Alpha contains 4 vowels. I will tell you how to do. Then total number of permutations. Whenever I use alpha, it means first condition satisfied. Whenever I would put alpha, all vowels together. So here see how many total 1, 2, 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial, but there is a repetition. There is a repetition. You can see m twice upon 2 factorial, t 2 times 2 factorial into 2 factorial. Any other repetition? No, you forget. Now your new letters. These are the new letters. Okay? These are the new letters. Okay? But now note alpha. In the alpha there are 4 letters. So would you multiply by 4 factorial? Then into 4 factorial. Why? Because they will switch their position by 4 factorial base. But because all are not distinct, 2 are repeating, it means 4 factorial upon, do you get this point? This is by this. Now I have to see alpha is what? Vishal. Alpha, there are 4 letters. So it means into 4 factorial, but they are not all distinct. Previously in that A, E, I, distinct, different. But here 2 are repeating. So how many repeated? You have to divide by factorial of that. That's why. Multiply by count correctly. 1, 2, 3, 4. 4 factorial, but you have to divide by factorial of repetition. Correct? If A 3 times, then 4 factorial upon 3 factorial. So this is the correct answer now. Okay, leave it. Now, if I ask when all vowels never together, then second part. Then total minus together, and total, how will I count total? Total, then look at the mathematics only. 11. So 11 factorial minus A is 2 times, A 2 times, A 2 times, A 2 times. So divide by 2 factorial into minus this answer 8 factorial upon 2 factorial, 2 factorial, 4 factorial upon 2 factorial. When you solve this, you will get the words in which all vowels never together. Correct? So this is how you will solve. By using the letters of the bird. Papaya. Papaya spelling correct? Papaya. Such that all vowels together. Okay. You solve. Take a minute and you solve this question. P-A-P-A by A. Papaya. I want all the vowels together. How many vowels so on? No, vowels is 1, but actually repetition, you have to count also, no? Actually it is 1 only, but 1 is coming 3 times, no? A 3 times. So here, first of all, vowels A and A. So what you will do? You will pack it in a box, and they will say it is alpha. Okay, it is alpha. Then remaining new letters. What are the new letters? P, P, Y, and alpha. P, P, Y, and alpha. So now how many? 4. 4. Then what is the answer? Your answer. Answer is what? 4 factorial. 2 factorial into divide by 3 factorial. because all 3 repeating na. So you cannot reshuffle. All A, only 3A. So A, only one arrangement. That's why 3 factorial upon 3 factorial. Actually it is 1. So it is 4 into 3 into 2 upon 2 into 1. 2 to cancel. Answer is 12. Okay, actually formula just for convenience. Concept always will be with you, because formula after sometimes if you don't revise you will forget, but concept anyhow you can remember what was the process. Okay, in first PU also I taught like this, correct now? If some particular letters together, pack in the one letter and say alpha. Whenever you use alpha, always using together. Next, now I will solve different category of questions. Okay, let me write the problem. How many ways 6 boys and 4 girls, 6 boys and 4 girls arranged in a row. Okay, arranged in a row. Actually write seated, what arranged, they are not the things. Seated in a row. If two girls if no two girls are together, if no two girls are together, okay, together. 6 boys are given and 4 girls are given. This category is actually important, and conceptually see how many given boys 6, okay, and girls 4. And what is the demand of the problem is 2 girls cannot sit together, baju not allowed, correct? So you will say like this, suppose there are 6 boys, I will say B1 boy, B2, and here is one gap, B1, B2, and then B3, again one gap, B4, and again one gap, B5, again one gap, B6, okay, B6, and again one gap, 6 Ys are print, correct? 6 Ys, 1, 2, 3, 4, 5, 6, all the 6 Ys are. Now if I say any girls go and sit anywhere, they will never be together, because these places only vacant, these places. So if girls sitting here and here, never together, na? Never together. But how many girls available? 4 girls, but places how many? 7 places. Then how they will sit? First of all, tell me how many ways boys can sit. All boys are different, and B1, B2, B3, B4, B5, B6. So boys can switch their positions, na? Suppose if I say B2 here, B1 here, no problem, na? It means 1, B1, B2, B3, B4, B5, B6. So boys will 6 by 6 factorial ways. 6 factorial ways. Now 4 girls available and 7 places available. Then how girls will sit? Total places. First you select the girls. Then how many ways? Think. One similar problem I will write, then you try to solve. Similar problem I will write. Array 7C for what? Slowly you will learn. Okay, this is just beginning only. You will master these things. Next question, right? Next. Okay, I will change this question and I will give similar problem. How many ways 10 boys, okay, or 7 boys? Delete. How many ways? 7 boys and 5 girls. Let's take 6 girls. 7 boys and 6 girls can be seated in a row if no 2 girls are together. Now you solve it. Okay, I am erasing the solution. Solve. How many ways 7 boys and 6 girls can be seated in a row if no two girls are together. Now 7 boys, so B1 to B7, B1 to B7. Suppose B1 boy here, B2 here, B3, B4, B5, B6 and B7. Then here gaps are given, 1 gap, 2 gap, 3 gap, 4, 5, 6, 7, 8 gaps available. So your answer will be 7 boys, and all boys are obviously different. So 7 factorial into 8C6, 8C into factorial 6, or else can I directly write 8P4, 8P6, 8P6. And what is the formula of NPR? Remember NPR formula, n factorial upon n minus r factorial. So what is the final answer? 7 factorial into 8 factorial upon 8 minus 6 factorial. So 7 factorial into 8 factorial upon 2 factorial is the answer.